Awesome. Okay. I've also started the recording. So let's start, and then as people join, they can just follow. Again, just welcome to everybody. We have a WhatsApp group, so you can send me a WhatsApp on 083-790-8387. The session will be, like, it is recorded at the moment, so it will be shared again on the YouTube page. So it will be there, so people can watch that as well. Okay, so today's session, basically, I want us to go through study unit 6. So study unit 5 was about discrete probabilities. So it was the discrete, the binomial Poisson distributions. Now we're going into the continuous probabilities. So now we're going to start with the normal distribution. There's other continuous probability distributions as well that we will later on look at. Square we will get to in study unit 10, I think. So there is another one, some of the other ones. There's other ones as well that we don't focus on in this course, so we don't need to worry about that. So let's get into the continuous probability distribution. And just again, like in the previous sessions, I just want us to work through a few examples. What I will also try to show is, how do I join? Ooh, that's weird. That so the person can be part of the chat, but not. Okay, we'll need to sort out that at some stage. Strange that the person can't join. I don't know if any of the guys that are on the chat knows how to let somebody join that is just following the chat. Okay, so basically I'm going to go through some of the beginning stages of the normal distribution. What I'm also going to show you is how I would normally look at it by drawing my normal distribution curve, and then also how to look at it with the tables. Okay, cool. You were able to join. Okay, so basically the first question, and let's just make it a bit bigger as well. So the first question that I want to look at is to say, okay, so we're using the standard normal table, so we will look at the table, and I think that is important that we look at the tables as well. So included in here will be, I've copied out of the book as well, the tables, so that I can show you how to get to the tables as well. And what they ask us is, we look at the normal distribution. So I always like to draw it. So let me just get. So I normally just draw something like that and assume it's a normal distribution. And then let's look at what they ask us. Use the standard normal table. Calculate the probability. So let me first do that. That is in the middle. So calculate the probability that Z is bigger than minus 1,6. So if that is 0, that's negative, that's positive. So we look at minus 1,65. And basically they ask us the bigger than. So we want that area. So that is basically the area that we are looking for. So what I first want to show you, so remember one of the criteria for a normal distribution is that is symmetrical. So what that means is 50% will sit here and 50% will sit on this side. So when I need to work out the probability of this, I already know that I'm looking for a number that is bigger than 50%. So if I want to start saying which ones can I eliminate out of my options, that one and that one I can already eliminate. Okay, so because I know my answer needs to be bigger than 50%, and those two are smaller. What is very interesting is that those two one of those two will probably be referring to that small area. The one which it is, I don't know yet because I need to go and look at the tables. So let's look at the table, and here you can use two tables. So the table that we're going to use here is the table that you would see in your book that would color in that whole area. Then there's another table that you can use that shows the negative numbers that would only refer to that portion. So basically, because it is symmetrical, if we're looking for a value of minus 1.65, we can actually look also for what is the value of a positive 1.65. So we can use this table where we look at where the Z goes down to 1.6, where it goes across to the 0.05, so the 0.05, and that crossing basically gives us that probability. So the probability would be 0.9505, which is option 4. Okay, so let me just show this again for you in a... So if that is minus 0.65 and I want that area, it is exactly the same as if I'm looking at the positive 1.65 and I'm looking at that area. So I think that is just one of the things that I also wanted to show you, that because of the symmetrical ability of the normal distribution, that is how you can also nearly see it. So I think the other, so that small part would have been the 0.0495. So that small part would have been that. but the correct answer is that, because we are looking for the bigger than area. Okay, so let me get a quick check-in from you guys. Are you happy with this one? I tried to bring in some other ways of looking at it as well, so that in the exam there is ones that you can really eliminate, and we'll basically do this for the whole session, is to look at these kind of things, so that we have this sorted out, because then it makes your confidence intervals easier. It makes your hypothesis testing easier as well. Okay, so that's one question. Let's go to the next one, and let's see what is sitting in this question. Okay, so they tell us the long distance calls made by the employees of a company are normally distributed. Okay, so by that we already now know that we can work with the mean standard deviation. So they tell us there's a mean of 6.3 minutes and a standard deviation of 22 minutes. Use the normal standardized table to calculate the probability that a call lasts less than 7 minutes. Okay, so we need to work out what is the probability that a call lasts less than 7 minutes. Okay, so basically how we do that is we need to go and look at the z function and how we calculate that. So that is z is equal to x minus the mean divided by standard deviation. So the x that we are looking for is 7. The mean is 6.3. And that we divide by the standard deviation of 22 minutes. Okay, this does feel weird, but it's fine. Okay, so it will be 7 minus 6.3 divided by 22. So we are looking for a z value of 0.03. Sure. Okay, and again, just look at the function. So we want the probability that z is smaller than 0.03. I hope I didn't miss anything. There's the mean. Standard deviation is also in minutes. Okay, so then basically let's just imagine that is a normal distribution. If we put it in the middle, we've got 0 for z. So z is just a bit bigger than 0. So 0.03. Okay, just a bit bigger than 0. So if it's just a bit bigger than 0, and we're looking for that space, remember that at 0, the 1 will be 0.5, and the other one will also be 0.5. So we're looking for probability that is just bigger than 0.5. Okay, so if I looked at my options again, that is not bigger than 0.5, so I would automatically have dropped that. That is not bigger than 0.5, so I would have dropped that. If I would have guessed, I would have guessed option 5, because that is very close to the 0.5, but let's go to the table. So when we go to the table, again, we look at the Z table, and the Z table that you guys would look at is the one that is positive, so it will have that area that it's colored in, so that coloring in area will basically look at that. Okay, so again, we saw it was 0.03, so we go down the Z table with 0.0. So just to, so those first two is what we go down with. That one is what we go across to. So 0.03 was 0.512. So then we can say that that area is equal to 0.5120, which will give us then option 5. Okay. Okay, so let me get another check-in with you guys. Again, there's about 6-7 of these things that we will work through, but does it make a bit more sense to you? Just want to get some kind of check-in. Or are you happy with it at the moment? Then we can go on to the next one. Nearly every time I want to show also just how we use the table and look at the table so that it just makes sense. You can shout if there's anything that I need to show again. So once again, they can ask this in a few different ways. So the first one, they gave us the, let me just, let's do the highlighter. They gave us it and told us to work out. The second one, they didn't give us something, but we needed to basically work Z. So we needed to go, I need to find out what that Z is, and then I needed to go and find the probability. So they give us the information to basically do that. One thing also that I just wanted, and that's why I nearly wanted to check if I'm doing the right thing, is just be very careful in the exam that it is, in all of them, it's minutes. It can be very easy that they tell you one of the components, the mean, the median, the mean, the standard deviation, or the X is in hours. So that you just, it's just more a tip than anything else. So just make sure in the question that everything is the same unit nearly. Because it could be that somewhere they say 60 minutes and then they say with a standard deviation of 1 hour. And then you nearly just want to use the one. So just in this instance, it wasn't like that, but just for exam to make 100% sure. Okay, so in the next question, again, they tell us, suppose Z is normally distributed, calculate the probability that Z is smaller or equal or smaller to minus 1.59. So again, the first thing that I would draw is my Z. So I know that is 0. Minus 1.5 will lie somewhere there. So again, I must get smaller than. So let's just make that a bit better. Smaller than, so I need to get this area. So again, things that I would look at, the easy one, that is 0.5. That is 0.5. So this will definitely be very much smaller than 0.5. So it can't be that one. So the first one can't be that, because it would then be somewhere there. We can't get a negative probability. So nearly by looking at the negative probability and there's a positive, I want to, before I even start looking at solving it, I would even go and say that is the right answer. But again, let's rather just see on the table what it is. Okay, so again, I'll look at the table. This time I'll use the negative table. So this one would look like that. There will be a smaller area for colored in, and it will have a negative sign. So we need to look at minus 1.59. So let's go. So now we need to go down this path again to get to the minus 1.5 and way across to that side to get to the 0.09. And that value then is 0.0559. So if we go back, so it was actually that one. So that was the one that then we needed to get. So that small area is the 0.0559. Okay. So again, I just want to give you some tips as you go through this in and preparing for the exam as well. So this one, more straightforward. They give you the Z. You need to go to the table to get to the answer. But with doing that, you can already cancel out one or two options. So again, if a pressure is on you and you need to, and you have not a lot of time to do the questions and rushing through a few of them, this is nearly also a way just to make it easier for you if you need to start. I don't want to say guess, but to make it just easier to get to the answer. Okay. Again, shout if there's anything I am missing, and if I need to show anything again. Yes, Precious.
Yes, I'm lost on the question that we are doing. I was late, it's not long time that I joined the group. But then I
Oh,
wanted to ask you,
yes.
the why on your graph on the other side is 0.5 and 0.5? How do you go on the table?
Okay.
Or
So
can you can you just explain maybe from the beginning?
okay.
I'm lost.
Okay. Don't worry. You will see. There's a few of these that we will go through.
Okay.
So that's why I'll happily explain again. Okay. So
Okay.
and I think what Precious, what the nearly one of the important things that comes out of a normal distribution, and I think that is maybe it's one of those things that it's one of nearly the definitions. So one of the things in how we can classify something as a normal distribution, or what happens is everything under the graph will be, as we know, probabilities, it will be equal to 1. So this whole area will always be equal to 1. So the probability under the normal distribution will be equal to 1. The other important thing is that when we look at the normal distribution, where the mean is 0, it is in the middle. So that is where Z is 0 in the middle. Okay, so that tells me that I split that 1 up in 2 and in 2 exactly the same sizes. So that then tells me that this portion will be equal to 0.5 and this portion will be equal to 0.5. Okay, so because both must be equal to 1, if you add them, if I split it in the middle, the one side is 0.5, the other side is 0.5. So the other thing is, if that is 0, then to this side, the numbers will be negative. To this side, the numbers will be positive. But the other nearly beauty about a normal distribution is, if I've got a number here that is 1, that area will be exactly the same size as where I have -1 on the other side. That is just how a normal distribution works. So this portion will be just as big as that portion. Again, purely because it is a normal distribution, and by definition, that is how it will work. So and that's why I always start.
Sometimes you can entirely trust your language. Yeah, don't go shy.
Okay. So let's do this one again so that we can just go through those steps, because I think if one gets that, it's nearly a very, I don't want to say easy process, but it makes a bit more sense. So that's why I always draw myself the normal distribution curve. Then I know in the middle is always the 0. So if they tell me I must look at -1.59, I know it's going to be on this side that is negative. And they tell me I must look for a Z that is smaller. So I need to look for something that is smaller. So the smaller is going to go to that side. Okay, if it was bigger, I would have gone to this side. So then out of this graph, nearly I can say, well, that small portion is going to be smaller than 0.5. So because it's smaller than 0.5, it can't be this one. What we also know about the probabilities, we can't get a negative probability. So that will never be allowed, that you can get a negative probability. So we can also cancel out option 5. Okay, so now I still don't know the answer. So I need to go to the table. So on the table, I need to get to the value of negative 1.59. So you would see in the study guide there's a Z table that is negative, and that small portion will be colored in. So that portion will basically always refer to a probability within the table. So we need to look at where it is 1.59 or minus 1.59. Your negative Z table will always start with a minus 3 at the top. Normally it won't go smaller than that. On the positive side, normally it will also not go bigger than 3. So we're going to look for the minus 1.59. So the 1.5 or the negative 1.5 is always in the area that is going down. So that is where we will pick up the negative 1.5. Then we need to go across to get to the that 0.09. So we need to go across to get to that. So there's the 1.5, across there is the 0.09. So where those two basically meet, that will be the probability that I'm looking for. Okay, so that small area then, the probability of that is equal to the 0.0559. Okay. As we go through the others, I'll follow exactly the same process, because that for me is how I do it as well. So because it just makes sense, and also if you go through that process, nearly it's you are training yourself to do it according to those steps. So let's quickly get to the next one. Okay, so here, because I always looking for what is the probability of Z being equal, smaller, greater than. So what is the probability that X is greater than? Okay, so we always look for something like that. They don't tell us that. So here they tell us X is normally distributed. You have your mean, which is 100. You have your standard deviation, which is 20. What is the probability that X is greater than 145? Okay. So basically we need to work out the Z. So the Z, we know the formula for when we don't get any sample. It is X minus the mean divided by the standard deviation. So it is X, which is the 145, minus the mean of 100 divided by standard deviation of 20. Okay, so that is 45 divided by 20, which is equal to, what is it, 2.25. Okay, so then again, let's just read what is the probability that X is greater than that. Okay, so what is the probability than 2.25? Okay, so then if I go to, even before I go to the table, okay, there's 0. So 2.25 will lie somewhere on this side. And what they tell us, bigger than the 2.25. So we're only interested in that small area. Okay, so again, that part is 0.5. That part is 0.5 because it's a normal distribution and the 0 within the middle splits it up. So I know again that part that I'm looking for must be smaller than 0.5. When I look at my options, then I'm like, okay, that is bigger than 0.5, so I can actually cancel that out. That is bigger than 0.5. I can cancel that out because it's not, that is bigger than 0.5. So I'm actually sitting with two options that I'm looking at. Okay, so now you can do this on two ways. So when I showed you here that whatever the probability with 1 is the same as the probability with -1. So if we look at the probability of -2.25, that will be just as big as the positive 2.25. Okay, so I can go to the negative table to look at the 2 or the -2.25. I can read it off from that. Let me see, what table do I have? Yes, okay, so from this one, I will just go to the negative 2.25 and I will get the 0.0122, which is option 5. But let me quickly, I want to copy in one of the other tables. So just give me a minute that I can just copy in a positive table as well, that I can just show you what we could have done if we only had the positive table. So just give me a minute that I can just sort out where my table is. Let's quickly get to it. Okay, so I'm just gonna see if I can quickly. I'm able to paste it in here. Okay, so what we could also have done, and let me put it there, is we could have looked at, needed to find the 2.25. Okay, so 2.25 is there. But remember, what this table is doing, it's not giving me that area, it's giving me that whole area. So that portion is this whole area, including that. Okay. So to get to that small area, I will then need to say 1 minus 0.9878, which would have also given me the 0.0122. Okay, so you can basically use both tables to, and nearly which one for you are the easiest to work with. And I think that is, again, it is open book. You have the tables, so it's not that they can't, you, because it could have been in previous exams, you can only have access to one table maybe. With this exam online, you've got access to both tables. You can use both tables. So the one that you are most comfortable in using, use that one. I just wanted to show how you can use both of the tables to get to the same answer. Okay. Anybody quickly want to ask a question? You can see there is still a few that I will go through. So, but if you quickly want to ask something, no problem. Or if it is starting to make a bit more sense, hopefully, I hope so. And also, I am recording this, so if later tonight, it will be put on our WhatsApp group again. So if you then want to nearly look at it again tomorrow or go through it again, do that, and you can always then WhatsApp on the group as well, so that we can just sort out if there's anything else that you need to get clarity on. Okay, so I just included this question from a definition point of view. Again, I don't see that they will ask a lot of definition questions, but we've now done a few of the questions where it says to us the normal distribution has a mean of a 0 and a standard deviation of 1. So if we see that, we know it is a standard normal deviation. Binomial can't be, because binomial is not a continuous distribution. Poisson is not continuous. And these two, I don't even know what they want to ask in those two. So it can only be standard normal distribution. Okay. So again, definition. So if they want to, they can ask you in a definition question, the normal distribution has the following characteristics. And then one of it is the mean is 0, standard deviation of 1. The probability under the curve will equal to 1. A normal distribution is symmetrical. So if they want, they can ask you those kind of things in one kind of definition question. But again, I think it doesn't make sense when you're writing an online exam to get something like that. So, but it can be in there. Okay, so the next set of questions is nearly to look at a few of these. First, I would gonna draw all of them and see if any of them I can nearly cancel out because of the things that I've nearly shown now through the way. But obviously there will be one or two that we need to go and look at the tables. Okay, so let's, they tell us random variable, mean of 0, standard deviation, it's standard normal. So we can automatically always say, okay, well, just imagine again that is a normal distribution. So what is the probability of Z when it is 1.52, that the probability is 0.0643? Okay, so when I now said so I looked at this, I would have said 0, 50% there, 50 there. So with this one, I can't say no. So I can't say that I know that this one is incorrect, and we're looking for the incorrect one. So I'm like making a exclamation or a question mark. Maybe it is right. So we will need to go to the tables, but I rather want to see if there's one that shouts out to me that is definitely wrong. Okay, so let's look at the second one. The probability, so it's a positive probability of 1 point, where the Z is 1.48, smaller than, so we're looking at this area. So again, if we look at the middle, it will be bigger than 0.5. So that is bigger than 0.5. Okay, I don't know. So maybe we need to go to the tables. Okay, so let's look at option 3. Okay, option 3, looking, so that is 0 minus 0.43. So it lies somewhere to this side, but bigger. Okay, so because it's bigger, it means that 0.5, it will be less, it will be more than 0.5, but less than 1. Okay, again, not 100% sure. Okay, option 4. See, so in all of them, I haven't looked at any tables yet, because for each one you would then need to go to the table until you get the one that is incorrect. So that is 0.74. We're looking for bigger than that. So we know that answer needs to be smaller than 0.5 because it's part of that. They tell us it is 0.7704, so that one is incorrect. Okay, because it is that portion, so it needs to be smaller than 0.5. It is not, so we can actually say that one is incorrect without going to any of the tables, because again, it's different if all of these values were the same for you, to go to the tables, then it's easier to, but otherwise you need to go to each one individually and see if it makes sense. Okay, so I nearly did the opposite now, to just by the theory and the definition knowledge that we now have nearly gained around the normal distribution, I could have pinpointed this without going to the tables. Okay, because again, if you look at this one, it's a more difficult one to calculate. So I would first try and get it through this way before I actually need to go to the tables. So I nearly, again, want to give you that tip instead of just going to all the tables, and there are normally ones that you can automatically look at to see if it works or not. Okay, so I hope that that tip will help you in the exam as well. So let's make this one a bit bigger that we can just check what is going on here. So a psychologist has been studying eye fatigue using a particular measure which she administers to students after they have worked for 1 hour writing on a computer. On this measure, she has found that this distribution follows a normal curve. Okay, so we know it's a normal curve. Using a normal probability table, what is the probability of students having Z-score below 1.5? Okay, that, I wonder if this is now as simple as, okay, so that is 0, that is 1.5. So what's the probability that students have a Z-score below 1.5? So we need to get that probability. So again, 0.5 this side, 0.5 on this side. So the probability that I'm looking for is bigger than 0.5. So in that sense, I could have eliminated those two. But I would just need to go to the table. So I don't have a table, so let me quickly copy this table in. Okay, so probability of 1.5, so I need to go down. Oh, there is 1.5. So it's 1.50. So the probability is 0.9332, which is that one. Okay, so this one was much more straightforward, nearly in, they tell us we're looking for a Z that is below 1.5, and that we can basically then straight read of the table, and that is what we are looking for. If I ask us what's the probability that the Z score is higher than 1.5, we would have then said, okay, we'll need to look at the other side. So 1 minus that would have been the answer, and then we would have had the answer of option 1. So again, I think that's also what will happen in the exam is, and let me just move this a bit, is that they would give you one of the options will be that portion, and one of the options will be that answer as well. So that you need to exactly know which part they are referring to. And we've seen that now nearly in all of the answers, that you would get the one that is smaller than, and you will get the one that is bigger. So just make again sure in the exam that you nearly read it correctly, that you're looking for something that's below. Okay, they could have said smaller than as well. or least van. So just all the naming conventions nearly that they can ask you or give you. Okay, so let's look at the next one, because this was a bit of a different one. So yeah, they're telling us nearly just for opposite. If the area to the right of a positive z, okay, so that is the 0, a positive z is on this side, so let's say that is the positive z. If that area is equal to 0,0869, okay, so area to the right of that, so this area, if that is equal to 0,0869, what is the value of z? Okay, yes, ask a question. I see there's a hand risen.
Yes, Jean. On the previous question,
Yes,
I saw we took the answer that is equal to 1 point. Yes, that is equal to 1.5, not less
yes.
than 1.5. So I'm a little bit confused on that one because they said
Okay,
it should be less than 1.5.
okay. So now I think what is important with when we look at the cumulative probability, and what is in the table is always the whole area from, so if that was 1.5, it is the whole area of that. So what that is why anything below 1.5. Um, when we deal with normal distribution, I think that's nearly the important thing is if I have said to us what's the probability of z equal to 1.5, then your probability is nearly zero because it's a continuous distribution. So it's not like the, the binomial and Poisson and the discrete that for 0.1 or for x equal to 1, it is 0.1 or something like that. Um, Here we're working with continuous, so they will always refer to below 1.5, so it means it is from 1.5 and smaller than that. So you will always include the number that they're referring to as well, just because it's a normal distribution. And I think that is the important thing. You will never, with a normal distribution, they will never ask you what is the probability that x is or z is exactly equal to 1.5, because that will never happen because it is a continuous distribution. And I think that is the important thing. So that is why you will always, so even if I set above 1.5, you will still include the 1.5 in the above as well, which makes it a bit confusing because you nearly want to say, well, it must be the one or the other one. But because it's continuous, it doesn't matter because you will look at 1.5 and then look at it what is up to 1.5. I hope that nearly answers your question.
Yes, sir.
Okay, cool. Okay, so back to this question. So So what we need to find is that Z value where that small proportion is 0,0869. So I know from my Z table, and I'll copy in it now here as well. I don't have that portion, I've got this portion. So let's see, that portion will be equal to 1 minus 0,0869. So that will be equal to, let's just quickly see, 1 minus 0.869. So that gives me 0,9131. Okay. And before we get to that even, they said to us, if an area to the right of a positive Z. So before I've even started working with this, what I should have done is go through the list, and I would have seen, okay, they say to me positive Z. Okay, so that can't be it because it's negative. Then I would have wondered, okay, they give me negative 1.36. Why would they also give me a positive 1.36? So I would have said, ooh, okay, that is maybe even the answer that I'm looking for. But there's also one that's big, so let's rather use the table. So that's why the table that I know covers that area. So let's copy this table into this one, and let's check. So I'm looking for a probability of 0.9131. So I know all of these numbers are probabilities. So in this table, I need to look for a number that is close enough to that. So here I look, okay, so 9.032, okay, not 9.92, so that is bigger than that. So I'm looking for 9. Okay, so let's just do that. So there's actually a number that looks exactly like that. Just want to make sure. 0.9131. Okay, so now we can check. So that is equal to 1.3. And if we go up, okay, 1.36. So 1.36. And that would have given us that number. I think what they also showed is in the textbook or in the other book is that you can look at the negative side as well, because as I showed in one of the previous ones, whatever happens on the positive side will also work on the negative side. So you could have used the negative table as well. Let me just do that and move it back into. So you could have used the negative table as well and would have gotten to the same answer. You would have used the, because that was the number that we were looking for, and then on the negative table, it would have been the minus 1,36. And see, that is where they wanted to trick you. So if you used the negative table, you would have thought, okay, it's negative 1.36, and then you would have selected the first one. But the question says we're looking for the positive Z. So we can then just make that positive into the 1.36. Okay, so again, very important what we are looking for. Okay, so we've got 2 more to do, and then we're done with study unit 6. Okay. Why does this look so familiar to one of the others? Okay, so again, looking for incorrect one. So again, I would do my process of looking at drawing it first for myself before I even go to any of the tables. Okay, so the first one says bigger than 2.64. So it's that area, so it will be a small area, so it could be that because it will be smaller than 0.5. Okay, don't know the answer yet, so let's go to the next one. Again, I will draw that smaller than minus 0.87. So again, we know that is 0 minus 0.87. So let's say it's somewhere there. We're looking for the area that's smaller. So it needs to be smaller than 0.5. So again, maybe it is that one. Okay, here we're sitting with one that is between minus 1.4 and plus 1.4. Okay, and they tell us what is that. Okay, so there we will need to do lots of calculations. So it can be that as well. Okay, so let's look at option 4. What is the probability that Z is smaller than 0.8? So smaller than 0.8. So that must be something that is smaller than 0.5. They tell us it is 0.9974, which is much bigger than that. So that is the incorrect one. Okay, this one is the interesting one because it's nearly what we've done in one of the previous ones that I wanted to show. So the probability of Z bigger than 0.74 will be exactly the same as the probability of Z smaller than the minus 7.4. Okay, so that will be equal to, and just because of the symmetry. Okay, so that one would have actually been correct, but the other ones you would have needed to calculate. So luckily, incorrect one. So without looking at the tables, we could have identified the incorrect one. Okay, last one. The last one we probably need to do a bit of work, so let's quickly see. The distribution of weights of a large group of high school students is normally distributed with a mean of 55 kilograms, standard deviation of 5. What is the probability of weights of a large group of high school students will be more? Okay, will be more than 63. So what's the probability that the Z is more than 63 minus 55 divided by 5? Okay, so what is the probability? Okay, so that we will work out again as 63 minus 55, which is 8 divided by 5 gives us 1.6. So what is the probability that Z is bigger than 1.6? Okay, so if I draw that again, and I will paste the table in now as well. So it's 0, there's 1.6. So it will be bigger than, so it's that area. So again, we know because that whole area must be equal to 0.5, that this portion will be smaller than 0.5. So again, can't be that, can't be that. Okay, so at least now we only have 3 to look at. So 1.6, I would, let's copy this one in so that we can just work it the other way around. So again, we need to get to, we need that area. This is referring to that area, so we need to say 1 minus whatever we get here will be equal to that space. Okay, so we're looking at 1.6. So here is 1.6 was that one. So 1 minus 0, 9452 will give me my answer that I'm looking for. 9452. So the answer that I'm looking for is 0.0548. Let me just write that a bit clearer. Okay. 0.058, which is option nearly, wait, it is, yeah, it is that one. Huh. Again, I just want to make sure because of the mixture of the numbers there. Okay. 0.0. Okay, so at least I just want to make sure. I don't know if I copied that wrong out of something or if that is maybe wrong in the textbook as well. But basically that is how we got to that. Okay. And very easily one can again make the mistake with the numbers. I nearly wanted to go with that one just because nearly your eyes want to say, but there is a 5, there is a 4, there is a 8. So that was then the correct one. Okay, guys, this was study unit 6 on the nearly the intro to the normal distribution. In the next session, we'll go into a bit deeper with this. Then we go into confidence intervals, hypothesis testing as well. Okay. Does it make a bit more sense? Is it a bit better? And does it help?
Yes, it makes sense.
Okay, cool. Okay. And yeah, we'll post the video a bit later as well if you just want to refresh again and work through it again. Okay, cool. Then I'll send calendar invites for next week that we can continue again with study unit 7. So have a good evening, and it's nearly weekend. So yeah, have a good evening everyone, and then we'll chat again next week.